In the recent years, the internet impact on finance has been huge, especially on the credit services. In the past, banks used subjective methods to judge the borrowers, like the 5C method, which wasn't very efficient. Now, online lenders are using technology like machine learning to make lending better and faster. This helps them handle many loan applications and ensure accurate lending decisions.
Scholars have extensively researched machine learning methods for credit assessment, including decision trees, neural networks, and logistic regressions. While traditional logistic regressions has interpretability advantages, it struggles with nonlinear relationships. To enhance prediction accuracy, a combination of both gradient boosting decision trees and logistic regressions effectively utilizes both raw and derived data. Alternative techniques like the naive Bayesian classifiers and decision trees bolster classification accuracy and interpretability. 2018's Li Jing's BP neural network introduced virtual information indices to refine credit evaluation. The role of soft information was probed by Jian Quiqiang in 2017 when they leveraged random forest models to merge soft and hard data, resulting in improved accuracy. To summarize, research has shown a diverse range of methods, including logistic regressions, decision trees, neural networks, and Bayesian classifiers to enhance credit assessment accuracy and predictive capability, particularly when considering the unique challenges posed by different data types and relationships in credit evaluation.
KNN classifier is a non-parametric and lazy learning method. It's explored for regression and classification. The model structure is dependent on the dataset, and there is no assumption for data distributions. It's widely used for classification because of low calculation time and easy of interpretation. It has the following working mechanism: compute distance, find the closest neighbors, and vote for labels. Decision tree. These are intuitive to visualize the decision. It is a type of non-parametric supervised learning method and decision support tool used for regression and classification. Based on the dataset, it can identify and derive a sign curve with a series of if-then-else decision rules. This algorithm uses the tree representation to solve the problem, internal nodes in the tree to represent an attribute, and leaf nodes to represent class labels. Random forest is the most popular algorithm. Namely, it assembles a large amount of decision trees from training dataset, and it also uses a tool called bagging to perform classification and regression tasks. Each decision tree represents a class prediction. This method collects the votes from these decision trees, and the class with most votes is considered as the final class. Naive Bayesian model is the reliable, fast, and accurate linear classifier, and it focuses on the conditional probability. Classifier technique is developed on the basis of Bayesian theorem, and it is suitable for high-dimension inputs because Bayes' theorems assumes the features and attributes are independent. This hypothesis simplifies computation, so it is considered as naive. Logistic regression is a powerful regression and statistical method for the classification problem, which is simple to conduct and can be utilized as the basis for binary classification problems. Additionally, describing and estimating the relationship between one dependent binary variable and the independent variables make this model instructive in deep learning. These assumptions are likely the same as those in linear regression.
Now to calculate the effectiveness of each model, we use the methodology presented on screen right now, which consists of different combinations of the true positive, true negative, false positive, and false negative to obtain the precision, recall, and accuracy of each model.
In order to understand the results proposed by the authors, we organized the models in ascending order by the area under the curve, and we paired up numerical and visual data to completely understand and gather conclusions by which is the best model out of the 5 analyzed. First off, we start with the naive-Bayes model, which we can see that it doesn't have a very high area under the curve with only 0.5% and actually a pretty low precision score. Next up, we have the logistic regression paired up with also the KNN model. Both of these are medium models since they do have medium precision and actually a high accuracy by which is over 80%. However, this is not the model that we're looking for since we want models with a much higher under the curve. Hence, we will continue looking for a better model. Finally, the decision tree and the random forest are models which have the highest R under the curve of them all, with 0.92. Since they have the same number, we now use precision, recall, and accuracy to understand the best model of these two, in which we can clearly see that the random forest is the best model to estimate tests done in this assessment.
To conclude, the authors reinforce the main points of the human subjectiveness in the traditional banking credit risk assessment, and hence why we should move on to models which are more effective and powered by machine learning, such as the random forest, which will increase the effectiveness of the data analysis and reduce the incidence of errors. And this all could be extrapolated to new industries and powered up with artificial intelligence to reach new sectors, such as construction, marketing, consulting, and even more.